Welcome to 8.3, solving systems of equations using the elimination method. So, in the past, 8.1, just to refresh your memory, was solving using the graphic method, where essentially, if we had a system of linear equations, we could graph each of these things. Each of them's a line, and really what we're looking for, the solution, is the intersection point of that line. And then in 8.2, we did the substitution method, where we were substituting an in. But recall that when we were doing a substitution, we were always trying to use one of the equations, solve for a variable, then substitute in the other one, so we'd end up with one equation with one variable. Now, the elimination method is what we're going to talk about today, and it's the same thing. Now, look at this first one here. Now, on the test, I won't specifically ask you to solve using one of the methods, either substitution or elimination. But on the next exam, some of the things are set up so it's going to be much easier to use substitution or much easier to use elimination, and that is really going to, you're going to need to know how to do both, and that will kind of dictate what you have. Now, if we look at this really quickly, if we're going to use the method of substitution, like we'd have to solve one of these two equations for one of the two variables, and if we're trying to solve the first one for x, we'd eventually have to divide by 9, and 5 is not divisible by 9, that'd be bad. If we were going to solve this for y, we'd have to divide by 5, that would be equally bad. The second equation, if we had to solve this for x, we'd be dividing by 2, 5 is not divisible by 2. Or if we were solving this for y, we'd have to divide by 5, and 2 is not divisible by 5. So this problem down here is classically one that would be fairly difficult using a substitution method. In fact, we'd end up with fractions, it'd be bad. But what we can do is we can always add two equations together. And you notice that it says add two equations together to eliminate one of the two variables. And we can do that here because notice this. We have a positive 5y and a negative 5y. That is, the coefficient, the numerical factor, that is 5 and negative 5. If we add those together, we get 0, thus we'd eliminate the y's. So we can do that. So here, let's look. If we have 9x plus 5y equals 6, and 2x minus 5y equals negative 17, if we add these two things together, 9x and 2x is 11x. The 5y's cancel or are eliminated. That's why we call it the method of elimination. 6 minus 17 is negative 11. Divide both sides. And notice, we have an equation with one variable. We can solve those. So if we divide both sides by 11 now, we get x equals negative 1. So that helps us solve for the x. Now, these solutions to these things are ordered pairs, so it's going to be negative 1 comma something. So to determine what the y value is, we do have to use substitution. In fact, I'll just plug that into this equation right here. So plugging that in for x, we have 2 times negative 1 minus 5y equals negative 17. Now this will help us solve for y, so we get negative 2 minus 5y equals negative 17. Add 2 to both sides. Negative 5y equals negative 15. Divide by negative 5, and we get y equals positive 3. So 1, 3, that's the solution. So notice when we're doing this, we want to make sure that the elimination, we're going to have the same variable that has the same coefficient but of opposite signs. So 5 and negative 5 are things that add together to get 0. So looking at the second one here, and I'm going to go back to this. Multiply one or both equations by a constant, so either of the variables have the same coefficient but of opposite signs. Now, this one here, if we look at it, 5x minus 9y equals 7, and 7y minus 3x equals negative 5. I'm going to write those so they are both x and then y equals number, and that's writing it in standard form. That's kind of going back to this first step here. So if we have 5x minus 9y equals 7, negative 3x plus 7y equals negative 5. So now that I've written it like this, we need to choose a variable to eliminate, either the x's or the y's. Now, I'm going to eliminate the x's for a couple reasons. One, 5 and 3, the coefficients of x, are smaller than negative 9 and 7, the coefficients of y. So that's kind of it. Now, because we have equations, we can multiply them by any number we want. As long as we multiply both sides by the same number, that's an equivalent equation. So if I'm eliminating the x's, this 5x and this negative 3x, I almost think about like what's the lowest common denominator. Or another way of stating that's what's the least common multiple of those? Well, If you think about that, denominators of 5 and 3, the lowest common denominator would be 15. So we want to think, well, what do we have to do to make this right here a 15? Well, we have to multiply everything by 3. So when we multiply 3 by 3, we're going to have a 15. Now we want the second equation to have a negative 15. So what do we have to multiply the second equation by to get this negative 3x to be a negative 15x? 5. So here we distribute. So 3 times our 5x, that gives us 15x. So then we have 3 times negative 9y, that's negative 27y. 3 times 7, 21. Distributing down here, we have 5 times our negative 3x, that's negative 15x. 5 times our 7y, that's plus 35y. And 5 times negative 5 is negative 25. Now notice, we've multiplied both of the equations by a constant, and we have a situation now where if we add these things together, we're going to eliminate the x's, which is the whole method of elimination. That's what we want to do. So adding these together, 15x minus 15x is nothing. Negative 27y plus 35, that's going to give us 8y, and this equals negative 4. Divided by 8, and we get y equals negative 1/2. Okay, so once again, our solution's an ordered pair, negative 1/2. That's our y value. To get our x value, we're going to plug this into one of these two equations, and it doesn't really matter which one. I'll go ahead and plug it into the second one. So if we have 5x minus 9 times 1/2 equals 7. So 9 times 1/2, we have 5x minus 9 halves equals 7. So add 9 halves to both sides. So we get cancellation over here, so it carries down as a 5x. Now over here, our 7 plus 9 halves, we need a common denominator. So multiply by 2 over 2. So that gives us 14 halves plus 9 halves, which 14 halves, oops, hold on. Okay, so sorry about that. Well, what happened here is I didn't plug in the negative. So if we have negative 1/2 here, that's a positive 9 halves, which means we're subtracting 9 halves here, not adding 9 halves. So subtracting 9 halves. So now if we have 14 halves minus 9 halves, that's going to be 5 halves. And finally we divide by 5. Now, here, when we have this, the division by 5 over here gets cancellation, so we get x equals. Here, that 5 is a 5 over 1, and we divide a fraction by a fraction, we flip and multiply. So we have 5 halves times 1/5. That 5 cancels with that, so x is 1/2. So y is negative 1/2, x is 1/2. That's the answer to that one. Now, looking at this next one right here, there's a couple things that are going on. One thing is that we have fractions. So we can, if you remember from Module 7, we can clear the fractions by multiplying everything by the lowest common denominator. Now, on the top, because we have denominators 3 and 7, we can multiply by 21 over 1. Same thing in the bottom. Lowest common denominator, 21 over 1. So when I do this, I'm distributing into each of these pieces. So let me just write this out. We have 21 over 1 times 2/3 x plus 21 over 1 times 1/7 y. And this is going to equal 21 times negative 11, which is negative 231. Now when I do my distribution on the second row, we have our 21 times 1/7 x minus 21 times 1/3 y equals 21 times negative 10, that's negative 210. Okay. Now, the reason why we're multiplying by that 21 is so we can get cancellation. So let's look at the cancellation. 3 goes into 21 7 times. So 7 times 2y, that gives us a 14y. 7 goes into 21 3 times, so 3 times 1y plus, oops, and this is an x, crap. to 14x. So here 3 times 1y is 3y, and equals negative 231. Here 7 goes into 21 3 times, so 3 times 1x, which is 3x. We have a subtraction here, so write that down. 3 goes into 21 7 times, so 7 times 1y is 7y. This equals negative 210. Now, once again, we're going to use the elimination method to solve this, and rather than eliminating the x's, I'm going to eliminate the y's for 2 reasons. 1, because 3 and 7 are smaller than 14 and 3, and 2, because they're already of opposite signs. The 3 is positive, the 7 is negative. So if we think about the lowest common denominator between those things, or the least common multiple, it's going to be 21. So I want to make these 21y's and a negative 21y, which tells me if we're doing that, we have to multiply the top one by 7. And the bottom one we're going to have to do by 3. So when we do this, 7 times our 14, 98x plus 21y equals, now 231 times 7 is negative 1617. Now when I distribute the 3 in here, 9x minus 21y, negative 630. Okay, so now notice we have our 21y and our negative 21y. We add these together. This gives us 107x. The y's are eliminated. And down here we have negative 2247. Divide by 107. And 2247. 107 is, so we get negative 21. So a solution to that, we get x equals negative 21. Now we need to find the y. Now we could substitute this, we could substitute this into a lot of different things. In fact, we could substitute this 21 back into these original equations, but we could also substitute that into these equations right here, the ones that don't have fractions. So what I'm going to do is I'm going to substitute the x equals 21, or negative 21, into there, and that's how we're going to solve for our y. So, plugging that into this equation right here, we have 3 times negative 21 minus 7y equals negative 210. So we get negative 63 minus 7y equals negative 210. Add 63. So 63, this is going to give us negative 7y equals negative 147. And then finally divide by negative 7. We get y equals 21. So an x equals 21, y equals 21, and that is the solution to the problem right there. See you on the next one.